Hey algebra students, it's Mr. Montes again, and we are back with another lesson. This week we are talking about factoring polynomials. Last week we were talking about multiplying polynomials, specifically binomials and trinomials, using an area model, which is going to be real nice for us when we start factoring. So the process of factoring is just where the reverse engineering process of multiplying. So I've written an example up here for you, or down here for you. 3 times 4, which is obviously 12. So the process of multiplying, like we were doing last week, was taking these two numbers and multiplying to give us 12. So the process of factoring is us reverse engineering this. We're given 12 and trying to figure out what we multiply to give us 12. The only difference here in this situation is that 3 times 4 gives us 12, but so does 6 times 2, 12 times 1, and I think that's it. Right? So each one of these, the 3, the 4, the 6, the 2, the 12, and the 1 are known as factors. Now, if I had just given you the 12 and I said I multiplied two numbers to give me 12, you actually wouldn't be able to tell me the answer. But fortunately for us, when we're dealing with trinomials and factoring trinomials, there's always going to be a unique answer. There's only going to be two factors that are going to multiply to give us the trinomial that we're looking for. Okay, so let's actually jump into that. Let me scroll over here. I got my example. Let's take a look at what we did last week first. Right? Remember we had the area model. Let's say we had x plus 5 times x plus 8, and we used what we called an area model or box method. If you can hear my son again this week, it's because he's upstairs. Ignore him. Okay, we got x plus 5, x plus 8, so x plus 5 and x and 8. And then I just figure out each piece in that square. So x times x is x squared, x times 8 is 8x, 5 times x is 5x, 5 times 8 is 40, and we end up with every single piece filled in, right? So now to find what the trinomial is going to be, we take x, we add each piece together, and then we also realize that 5x and 8x are like terms, but I'm going to go ahead and write those out off to one side. 8x x squared plus 5x plus 8x plus 40. Okay, combine like terms, and I end up with x squared plus 13x plus 40. And I want you to notice something here, right? So take a look at 5 and 8, right? Notice that 5 and 8 come from here, 5 and 8. And 5 times 8 gave us 40, but when I added 5 and 8, it gave us 13. So let's say I was trying to take this thing, and I was trying to reverse engineer this thing. So it turns out that this situation is pretty unique. What we actually are going to look at is this 13 and this 40, and we're going to think of numbers that multiply to give us 40, right? Because that's how we got 5 times 8 give us 40. But when I add 5 and 8 together, or the two numbers that I don't know about, give us 13, right? So it turns out in this case that it's 5 and 8. Notice that we have a 5 and an 8 here. Now, this situation is pretty unique. It works out only because we have a leading coefficient of 1 here. When it's not 1, there's actually several more steps that we need to take, but we're not going to worry about that right now. We're just going to deal with simple trinomials for now. Okay, so here's what we're going to do. We are going to show you a technique for factoring. Suppose I said factor x squared plus 13x plus 40. And the nice thing about mathematics is people typically come up with techniques, and then we just use those techniques to help ourselves out, right? We're going to call this the X game. We're going to draw a big X, and that was terrible. Much better. Okay, in this X game, we are really looking at locating, finding two numbers, and those two numbers are actually going to be located here and here, right? And those are going to be our factors. And again, let me just reiterate, this only works out easily like I'm going to show you right now because the coefficient here is 1. If it's not 1, there's actually a few more steps that we need to take. All right, so what we have here we're going to have the product. So this top corner right here is going to be the product. So in this case, it's going to be this number, this 40. So I'm going to write down 40. Down here, I'm going to write down the sum of those two factors, which in this case is 13. Now, this will always be the product, and this one will always be the sum. And I'm going to show you this in a second, but we recognize this as letter C and this as letter B, and I'll show you where those come from in a second. Now, we're trying to think of two numbers that multiply to give me 40, but add up to give me 13. What are the two numbers? Well, let's think. We don't have to think. We actually have this right here, don't we? 5 times 8, right? So then we would write 5 and 8. And those are our two numbers. So this, excuse me, the simple trinomial factors as x plus 5 and x plus 8. Easily verified by scrolling up, right? So what does this look like if we didn't know, right? So we got to give you a few things first, right? We're going to give you the generic form of a quadratic. Quadratic, ax squared plus bx plus c looks like that. Now, I'm going to erase the a, b, and c, and let's make them color chunked. Let's go ax squared plus bx plus c will be in purple, bulldog purple that is. So each one of these letters in front here, it represents a coefficient. This right here is the quadratic or quadratic coefficient. This is the linear coefficient, and this is the constant coefficient. So when we do the x game, and I'm factoring, in this case, whoops, in the case of our situation, we are not dealing with anything, the coefficient of a being anything other than 1, so I'm going to erase that. So really, for the x game, we're thinking of what times what gives me c, but when I add it together, it gives me b. And remember, the whole goal right now is to go backwards. We want to be able to write them in that form, right? So it's in this trinomial form. We want to be able to factor it. And so we're going to use this x game where I use the c. What times what gives me c? And you know what? Let me write. So this is multiplication. But when I add those two together, it gives me b. This is addition. This is multiplication. All right. So let's actually try this out. Let's go. Let me scroll down just a little bit. Let's go. I have an example here. Right here. Okay. Let's go b squared plus 8b plus 7. And I might say something like factor. Okay. We're going to play the x game. I'm going to identify my b and c. This is my b. Not to be confused with little b. It's big B. It's the coefficient of the variable. And then we have my c. So this is b and this is c. So I'm going to draw my x. And I'm going to play this x game. So we're going to think about what times what gives me 7. So what two factors give me 7 when I multiply them together? But when I add them, give me 8. Remember, this is addition, and this is multiplication. So I'm trying to think two numbers. Well, in this case, it's pretty straightforward. There's only two numbers that multiply to give me 7, because 7 is what we call a prime number. So in this case, it's just 1 and 7. Okay, 1 times 7 gives me 7, but when I add 1 and 7, that gives me 8. So that gives me the two factors. So this polynomial factors like this. b plus 1 times b plus 7. and you're done, right? So a question might be, does this always work? If the trinomial is what we call factorable, then it does work out like this. Not all polynomials are going to be factorable, but we are not going to look into those yet, all right? So that's one example. Let's do another one. Let's go, draw a line here. Let's use n squared plus 4n minus 12. And again, we're going to factor. Let's identify b first. B is the linear coefficient. It's the right here. That's our b. And then c is going to be all that. It's actually going to be the negative 12, not just positive, but negative 12. So this is c. And we're going to play the x game so we can try and factor it. I already know some pieces here. I know this is going to be n and n. And I'm trying to find two factors such that when I multiply them together, I get negative 12. But when I add them together, I get 4. So this is this is addition, and this up here is multiplication. Now, this one's a little bit more difficult, and it has to do with that negative 12. Because now we're thinking, what two numbers multiply to give me negative 12? But when I add them together, they give me 4. Right? So there's some obvious things out there, right? So let's just start tossing them out because there's multiple things that would work. We know 3 times 4 gives us 12, equals 12. We also know 6 times 2 equals 12. And we also know 1 times 12 equals 12. And I think that's all of them. Okay, so I have here 3 different options, but unfortunately 3 plus 4 is not 12, 6 plus 2 is not 12, and 1 plus 12 is not 12. However, we're not looking to get positive 12, we're actually looking to get negative 12. And to make it negative, that means one of these numbers here, either the 3 or the 4 has to be negative, right? If I make the 3 negative, this would give me negative 12. But what's negative 3 plus 4? Negative 3 plus 4 would be positive 1, which is not 4. So that doesn't work out. So let me get rid of that. Well, maybe it's the 4 that's negative. 3 times negative 4 is still negative 12. But 3 plus negative 4 is now negative 1, which is not 4. So it's not that one. So it can't be that one. Let's try 6 times 2. So what if this were negative? Negative 6. Negative 6 times 2 is negative 12. But is negative 6 plus 2 4? Negative 6 plus 2 would be negative 4. So we're getting close. What if we switched it around? 6 times negative 2 is still negative 12. But is 6 plus negative 2 4? It is. These are my factors that work. I need a positive 6 and I need a negative 2. So I just have to write these in. N plus 6 and minus 2, and I'm done. Right? So we can actually verify it. Suppose you said, Mr., how do I check my work? Well, that's pretty straightforward. To check your work, all you have to do is multiply that out. And I could do that by using another trick, a little area model, right? So let's try this. Let's say n 6, and then I wanted n and negative 2. N times n is n squared. Negative 2 times n, 6n, and then negative 12. Okay, we have like terms here. So we have n squared, 6n minus 2n, minus 12. Like terms, right? N squared plus 4n minus 12. Did we get the same thing? Yes, we did. That is what we started with. So our answer is correct. Now, if you look at the PowerPoint, there's there's a few more examples that you all could take a look at. Hold on, let me get rid of that. Go ahead and take a look at those. The solutions of those are posted in the PowerPoint. And then again, this week we do have an assignment for you. Go ahead and take a look at the assignment and make sure you try those problems. If you have any questions, concerns, complaints, any groans, anything, contact your math teacher, contact me. contact somebody and let them know. Sounds good? All right. Well, that's it for today. Hopefully you learned something, and we'll talk to you soon. Stay safe out there.